Today we will start with the solution of simultaneous differential equations, which is again an application uh, of Laplace transform to find the transfer function of a given system or to solve uh, the input and output inputs or the outputs of the system. Okay, right now. So I think I have given you an example how to represent a system using multiple simultaneous equations. Correct? Okay. Now let's directly go to a problem to understand the concept. Okay. So problem number one is this one: dx of t by dt plus 4 times y of t is equal to 0. dy of t by dt minus 9 times x of t is equal to 0. We will have the initial conditions. Okay, so this is x of 0 is 0, y of 0 is 1. Okay, let me modify this. Let's make x of 0 is equal to 2. Okay, solve the simultaneous differential equations. The approach is normal. What we can do now is we can apply the Laplace transform to both the equations, and we can see what we can do. All right. So taking Laplace transform, so it's a dx of t by dt. So that has to be s into x of s 4 times. This is y of s equals to 0. And the second equation becomes this is s into y of s minus 9 times x of s equals to 0. Okay, since it is we are applying the differential equations and we are trying to solve, it's expected that you apply the initial conditions as well. All right, so uh, I have to include even the x of 0, etc. Right? So let's see, I'll just slightly modify. I didn't write the initial conditions here. So s into x is minus x of 0, right? Should be applied because this and this should come together, right? I missed that, so please note that. Okay, so the Laplace transform of dx of t by dt is s into x of s minus x of 0. What should happen here? I should add a minus y of 0 equals to 0. Okay. Now, since the values are already given, let's substitute and let's see what we can do this. Okay. X of 0 is how much? That is 2. Right. So this s into x of s plus 4 times y of s minus 2 equals to 0. So minus 2 goes to other side like s into x of s plus 4 times y of s equals to okay, minus 2 becomes plus 2 now. 2. Okay, similarly the other equation, this implies s into y of s minus 9 times x of s minus y of 0 was 1, right? So this is minus 1 equal to 0. So as a result, s into y of s minus 9 times x of s is equal to plus 1. Okay, so let's call this as 1 and this as 2. Now I have an option to find either y of s or x of s so that I can find the other one later, right? So if that is the case, I slightly modify the equation number 1 like this. So I'll write the term containing y first. So that is 4 times y of s plus s into x of s equals to 2, correct? Now I can see that the first equation, I'll call this is 3, right? So now I need to make their terms equal. Then any one of the terms to be equal, either the first one or second. So I multiply the first equation by s, second equation by 9. Okay, equation number 2 into say s. This gives, so s square into y of s minus this is 9s into x of s equals to s. Call this is 4, and equation number 3 I will multiply by 9. Okay, uh, 36 y of s plus 9 s x of s equal to 18. So I think when I add, these two terms will get cancelled, right? This is s square y of s plus 36 y of s equals to s plus 18. So now on the left hand side, I can see y of s common. Y of s into this is s square plus 36 equal to this is s plus 18. Therefore, y of s becomes equal to s plus 18 divided by s square plus 36. Now, now you apply any of the standard inverse Laplace and try to find out what is y of t. Sure, take your time. Yes, yes, possible. That's also valid. Yes, right. That's right. So, if you want a sign, what is the requirement? I'll write as you what you know. So, Ts by s square plus 36, correct? So, which is a square? I can observe that a is 6 here, right? 6 square, right? Plus, this is actually 18 divided by s square plus 36. So, I can see that I need a square here. So, let me bring in the same format. This is s square plus 6 square. First one term is fine. Second term, what do you need in the numerator? You have to get not 36. You need a, right? A by a square plus a square. 6. So can you take out 6 from 18? Yes, possible. 3 remains, right? So 3 into, this is 6 divided by a square plus 6 square. It's done, right? Now you take the inverse. This is y of s. So applying L inverse, y of t is equal to, what's this first term? It's simple cosine function, right? Cos of at, so 60 plus 3 times the, huh, correct, this is sine 60 is y of t. Now use any of the initial two equations we have to convert this y of t into x of t. Okay, we have one equation which says that uh, d y of t by dt minus 9 times x of t is equal to 0, correct? So this says 9 times x of t is equal to dy by dt, dy of t by dt. That means this implies if you want to calculate simply the x of t, it should be 1 by 9 times derivative of the y. Just substitute and calculate. So this is equal to 1 by 9 times differentiation of cos 60 is minus 6 times sine of 60. Then we have plus 3 into 6. So this is 18 cos 60. So 6, I can take out, I think, 6 outside. So 6 by 9 is 2 by 3. So this is, hello. Can you see the screen now? Okay. So the final answer is, yeah, minus. I'll write the positive term first. So no, no, minus you keep inside, but I write the positive term first. So this is 3 cos 60 minus sine 60. Yes. So when 6 goes, 3 remains. That 3 I am writing here. Okay. Writing the positive term first. So, okay. All right. Now, let's move to the next question. This is d x of t by dt minus 2 times y of t is equal to cos 2t, and dy of t by dt plus 2 times the input x of t is equal to sine 2t, and the initial conditions are x of 0 is 1 and y of 0 is equal to 0. So this is the given condition now. So normally we start the solution by taking the Laplace transform. So what happens when you take the Laplace of the first equation? It is s into x of 0, right, minus 2 times y of s equals to, it's a it's a Laplace of cos 2t, s by s squared plus 4. All right, then applying the Laplace of the second equation, you get into y of s minus y of 0 plus 2 times x of s is equal to, this is a, so that is 2 divided by a square plus 4. The initial conditions, the initial condition is that x of 0 is 1, correct? So this implies s into x of s s into x of s minus 1 minus 2 times y of s is equal to s by s square plus 4. So take 1 to other side. Yes, 1 plus yes. Yes. Let's hold on to this. Let's not simplify this. Let's see what we get with the other equation. Then we'll simplify. Okay, I'll call this is 1. In equation, I'll apply the initial conditions first. So this is s into y of s. Y of 0 is 0, so we will not write that. Plus 2 times x of s is equal to 2 divided by s square plus 4. So this is the equation number 2. I'll modify equation number 1 as per the requirement of this. Okay, so equation 1 can be rewritten as minus 2 times y of s plus, this is x, s into x of s equals to 1 plus s over s square plus 4. Call this is 3. Now you can see that if we can cancel the y terms easily because there is opposite sign. Just multiply equation 2 by maybe s, sorry, equation 2 by 2 and equation 3 by s. Multiply with that, right? So this is equation number 2 multiply with 2 into 2. So this gives 2s y of s plus 4 x of s equals to, this is 4 by s square plus 4. I'll call this is equation number 4, and Third equation I need to multiply by what? Multiply by s, I guess, right? So this is minus 2s into y of s plus 4s 4s is it? S square is s square x of s, my mistake. So this is plus s square x of s equals to, this is s plus s square over s square plus 4, correct? Now I'll call this is 5. I try to add them up and these two will get cancelled. So I'm left with, so this is 4 times x of s plus s square into x of s is equal to, this is 4 by s square plus 4 plus s plus s square over s square plus 4. Okay, now yes, on this side I'll take x of s is common, x of s into, this is s square plus 4 is equal to, so on the right hand side I'll write s first, this is, then the remaining terms are same, right? This is simply 4 plus s square divided by s square plus 4. It cancels, right? It's the same term, it's 1, right? Words I can rewrite this as x of s into s square plus 4 equal to s plus 1. Yeah, correct. Therefore x of s is equal to s plus 1 over s square plus 4. So any method is fine. It looks like a standard one. We can directly come back to the, so how do you write this? Therefore x of s is equal to, you will split it, right? So s square plus 4 plus 1 divided by, so convert this into the, maybe you have to multiply the second term by, right, 4 2, multiply and divide by 2 to this number. 1 by 2 sine 2t, because the 1 by 2 is in the denominator, right? So this is applying L inverse. X of t is, what's the first term? Cos 2t plus, there is a 1 by 2 into the 2 by s square plus 4 is a sine function, sine 2t. So we got the x of t now. Apply any equation, any standard equation given, and convert this into the y of t. This implies, please find this. Huh. cos 2t plus, right? Plus or minus? Huh. Okay. X of t we directly get, right? X of t is the answer we get by solving the equation, right? Just now we applied and we just, so that is x of t. Now substitute in any of the other equation to get the y of t. For example, let me consider one equation. So, okay, I think we have the equation like, huh. Oh, okay, okay. So x of s we had, we took the L inverse, we got x of t. Till here, fine, right? Okay, now let's apply this. We know that dx of t by dt minus 2 times y of t equals to, I think, that's a cos function, cos 2t. This is given, right? Now you uh, convert this into y of t. This implies if you want to calculate y of t, it goes to other side. So there is a 2, so it becomes half of dx of t by dt minus cos 2t. All right. So apply the x of t here and differentiate that and get the answer. By 2 cos 2t and there is another cos 2t present, right? Will it get cancelled? Can you check? I'm just cross verifying. Yeah, so you have a cos 2t inside. I think the derivative will also generate a cos 2t. So since the sign looks opposite, I am expecting them to get cancelled. Hmm. So is the required y of t. Okay, we'll go for a difficult question now of this category. So this is dx of t by dt minus y of t is equal to e to the t and dy of t by dt plus x of t equals to sine t with the initial conditions x of 0 equals to 1, y of 0 equals to 0. So what's the first step? We take the Laplace. Okay. In the Laplace transform, the first equation becomes s into x of s minus x of 0 minus y of s equals to, what is the Laplace of e to the t? 1 by s minus 1. All right. And let's go to the second equation now. So this is s into y of s minus y of 0 plus x of s equals to, what's the Laplace of sine t? 1 by s squared plus 1. Okay, now let's apply the initial conditions. X of 0 is 1 and y of 0 is 0. Correct? So this implies s into x of s minus 1 minus y of s equal to 1 over s minus 1. So s into x of s minus y of s equals to 1 plus 1 over s minus 1. I'll call this as equation 1. I'll do the same thing with the second equation. That means it is s into y of s minus, there is a 0, plus x of s equals to 1 by s square plus 1. Okay, so right, so we can rewrite this as, anyway, the 0 doesn't count, right? I'll call this as equation number 2. So in order to make the equations equal, right, what can we do now? So can I multiply, there is a y of s with the opposite sign in the previous one, so I'll slightly modify this, right? So equation number 2, anyway, I'll modify, that is uh, x of s plus s into y of s equals to 1 over s square plus 1. So this is equation 2 itself. All right. Now, equation 1, there is a s into x of s minus y of s. So I multiply by s means y of s can be cancelled. Correct? So equation 1 into s is what I'm going to do now. So that means it is s square x of s minus s into y of s equal to, this is s plus s by s minus 1. Just verify once. Okay, right, now you can add equation 2 and 3. So this cancels. So this is x of s plus s square into x of s equals to, by s minus 1 plus 1 over s square plus 1. This implies 1 plus s square into x of s equals to this s plus s over s minus 1 plus 1 divided by s square plus 1. So we need to move this to the other side. So this implies x of s is equal to s by s square plus 1 first term plus the second term is s by s minus 1 into s square plus 1, and the last term is 1 divided by s square plus 1 the whole square, right? Every term gets divided by s square plus 1. So now you see that if you want to go for the inverse Laplace, separately you can take the Laplace inverse. This one, Laplace inverse of this one, Laplace inverse of this one, right? Three terms separately we'll take, and then we'll write the answers all together. So since different type of calculation is required for different term here, so this kind of problem falls under a different category. Okay, it's not a straightforward thing, right? Inverse Laplace needs some calculation here. Okay, so let's look at the term by term item. Okay, so that is, let's write L inverse of first term s by s square plus 1 is straightforward, correct? S by s square plus e square. This is cos t. This is done. All right, so we'll hold on to this. Okay, I think we wrote equation still 3, right? Okay, let me call this is equation number 4. Then step by step, I have to do three different calculations now, right? So now this is not a standard one, right? So I cannot apply any standard Laplace. So I have to, maybe mostly it looks like I have to write it as a, what do you call, partial fraction first, then we get an answer. Okay, so this is s by s minus 1 uh, into s square plus 1 is what I want to calculate. So we'll apply this as, this is, I keep L inverse outside. So this looks like there are two terms, and one of the term is not a simple term. This actually has, right, the complex root. When you take a root, s square equal to s square plus 1 equal to 0 means s square equal to minus 1. So whenever that happens, if you remember the partial fractions, right, we'll write it in this way. So first term, no issues. This is a divided by s minus 1. Okay, but the second term, because the power is 2 and it's not a simple fraction, right, you have to write bs plus c, bs plus c over s square plus 1. Now we cannot solve it in a very like we used to do for a simple case, right? We used to substitute s equal to something and we can, right? That's actually not possible right now. So we, what we can do here is that let's try to convert, or let's take the terms on which are present inside, let's cross multiply, in the sense this term is getting multiplied to this, right? So that some terms will cancel. So right, so we'll apply the L inverse later. So as of now, just leave the L inverse and write the equation. On the left hand side, I'm going to left with uh, I'll be left with s. S equal to, multiply the denominator to the other side. So a into, you can see s minus 1 already exists, so it will cancel. You get s square plus 1 in the numerator, correct? Plus second term bs plus c you have. When you multiply by this term over here, right, s square plus 1 will cancel. So yes, so that means I'm going to have s minus 1 over here. Just verify this step once. It's okay, right? Okay. Now let's think of cancelling uh, any of the terms, right? Let's try to cancel the term on the right hand side. That means let me try to cancel this term. If you want to cancel this term, this has to be 0, right? Only when you multiply by 0 to something, it becomes 0. So what s value you are supposed to put to make this that term 0? S equal to plus 1, correct? So when s equal to plus 1, the second term in on the right side will be 0. But I'm still left with this a. I can find what is a, right? So put s equal to 1. This implies left hand side is 1 equal to a into this is 1 plus 1, 2 plus 0, right? See, a is equal to half. You got it. Okay, now I know A, and if I have to find C or B, yeah, we can find BI, not B, C, I guess. If you want to find C, you have to make the term B into something that is 0. So that is possible if you put S equal to 0, right? Put S equal to 0. This implies left hand side is 0 equal to, anyway, A is half, right? Half into this is 0 plus 1 plus, so you see b into 0 is a 0, 0 plus c into this is 0 minus 1, so this is half minus c equal to 0, so c is equal to, right, half minus c, so c goes to other side, c also half, I guess. Just verify. C is half. Now what's the value of b? Yeah, please find b now. Yes, 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 you can find b. Many methods exist, just any other value you can put and you can find, I guess, right? b equal to 0. What you substituted? Hmm. A and G. What? But you have a value of S, right? What value of S you going to use? No, if you put S equal to 1, the term B cancels. So you cannot put S equal. Put S equal to 2, okay, or minus 2. Any other value other than the one which we used just now. S equal to 1, S equal to 0. You leave it like it. Okay. Other than those two values, any other value, maybe 2 will work, I guess. So left hand side becomes 2 is equal to A value we know half of 2 square plus 1 plus B as it is. S is equal to 2 plus C value is also half into S minus 1. Again that is 2 minus 1, which is 1. Yeah, I mean you're going to put S equal to 2. That means left hand side is 2 is equal to A value is known to you. So this is half of S square 4 plus 1 plus B into this is 2 plus C value is half into this is 2 minus 1. So this is the equation which you have to solve now to get the value of B. Yeah, B is equal to minus 1 by 2. This is right. I'll tell you another simple method. Okay, so whenever we face such situations, you can solve the same thing with the easier way. Okay, that is again this is widely used in partial fractions to find the coefficients, right? You can compare the uh, what you call coefficient of s square and constants on both sides. I think you are aware of that. For example, to find b, you see what is the if I simplify this, what is the equation that I am going to get, right? I might get something like a into s square plus a into 1 is a, right? Plus sorry, plus bs is there, so bs into s is bs square, correct? So b is going to get a s square ultimately. So I will compare the coefficient of s square on both the sides. What is the coefficient of s square here and what is the coefficient of s square on the other side? So this is the alternative method. It's very quick. Okay, it's very easy. That's why I just use this now instead of the one which we did now. You can use this. So this is comparing the coefficients of s square on both sides, right? Both sides I'm referring to the main equation which we have written down. So right, this equation. So what is the coefficient of s square on the left side? On the left side, left hand side, I don't see a s square. Then that's a 0, correct? Okay, so that means left hand side is 0. 0 equals to what are the coefficients you have on the right side? Yeah, you have a and b, right? Just check. right? Because c gets a multiplied, see, when c gets multiplied by s, you get cs, and c into 1 minus 1 is minus c. So anyway, they are not going to be counted for coefficients of s square, right? So it is simply a plus b, right? So find b now. So b is equal to minus a. What is a? A half. So this is minus half, you see, solved. So again, this is another, multiple methods do exist. This is the easiest one when to find when you know few of the coefficients and remaining you want to find. This works well. Okay, right. So now we got values of a, b, and c. We'll substitute right back in the equation. Right. Therefore, I'll put this. This implies the our main intention was to calculate this. Right. L inverse of s divided by s minus 1 uh, into s square plus 1, right? So what is that now? This is, I have to write a now, right? So this is a is half divided by, okay, this is Laplace inverse of, I'll still have to keep the L inverse over here. So, right. So this is L inverse of, this is a, so a is half over s minus 1 plus the b value was minus half bs plus c, which is half, divided by s square plus 1, right? Anyway, we can directly split this into uh, three equations. So this is equal to Laplace inverse of first term half over s minus 1, then minus half. Okay, Laplace inverse I can even write after that. So Laplace inverse of s by s square plus 1, right? Plus half L inverse of the third term, that is half over s square plus 1. So I think it looks like straightforward substitution, right? So it's a standard inverse. So it looks like half is common for every term, right? So e to the t, right? First term, okay. E to the t minus cos t, then okay, I wrote the, no, I think I wrote the half already outside. This is my mistake. Please correct. So this is 1 divided by, okay. So it's standard 1 once again plus sine t. This is what we get. And we have another term coming up, right? So the next term is in the main equation we have a third term to be considered, right? I think we wrote only first two terms. Okay, the last term is L inverse of 1 by s square plus 1 the whole square. Okay, so L inverse of 1 divided by s square plus 1 the whole square. Okay, so do you have any method to find this out? It's actually one of the standard one. I'll write the formula first. All right. So if, let me write like this. So this is the standard formula: 1 by s square plus a square the whole square. If you have something like this, its its Laplace inverse is 1 over 2 times a cube, right, into sine at minus a t into cos at. Okay, so this is the standard formula. That is applicable for Laplace inverse. All right. So any Laplace inverse you want to take, you can apply this formula, right? In the standard form. Now applying this to the L inverse of 1 by s square plus 1 the whole square looks like a is 1, right? So replace every a by 1. So that becomes it's 1 by 2 times 1 cube, 1 by 2 into this is sine 1 into t minus a is 1. So this is t into cos t. Okay, right. So clubbing all together. So this implies the function is x of t, we are calculating. First term, we got cos t, and the second term, we got this is plus half e to the t minus cos t plus sin t. And just now we got plus 1 by 2 into sin t minus t cos t. Okay, we'll club the terms together. I think the half we can write as it is into, so e to the t will be there minus t, and if I multiply and divide by 2 to the first term, 2 cos t by 2, so that is one of the two minus 1, so I have 1 cos t coming in, so this is plus cos t, and I have sin t terms, one here, so 2 sin t plus 2 times sin t minus t cos t. So this is what we get as x of t. Because we have a sin t here, but another there are two sin t's, right? So half anyway you are taking it out, so sin t plus sin t is 2 sin t, right? So this is the x of t, right? uh, there is one part left, that is finding y of t. Okay, use any of the given equation, right? And calculate the y of t by yourself. We'll verify the answer in the next class.